In an ideal Brayton cycle with intercooling, we know the input data for the devices. What is the turbine outlet temperature? What is the work generated by the cycle? In Thermonator, we configure a control volume exercise, since it is an open system. We select the sign convention that considers the work generated by the system to be positive. We also configure power units, because mass has units of time. We could create the cycle quickly using the New Cycle menu, but in this exercise, we will create the processes one by one. We enter the inlet pressure and temperature to the first compressor and click Calculator to calculate the state with those properties. We select the Adiabatic menu and create the process for the first compressor. We enter the outlet pressure of the first compressor and click Calculator to calculate the state with this pressure and the entropy of the adiabatic process. We select the Isobaric menu and create the intercooler process. We enter the intercooler outlet temperature and press Calculator to calculate the state of the isobaric process at this temperature and pressure. We select the Adiabatic menu and create the second compressor process. We enter the second compressor outlet pressure and press Calculator to calculate the state of the adiabatic process at this pressure and entropy. We select the Isobaric menu and create the combustion process. We enter the combustion outlet temperature and press Calculator to calculate the state of the isobaric process at this temperature and pressure. We select the Adiabatic menu and create the turbine process. We enter the turbine outlet pressure and press Calculator to calculate the state of the adiabatic process at this pressure and entropy. We select the Zoom menu to adjust the graph. We define the cycle mass as 10 kilograms per second by pressing the Calculator button. Selecting the Calculations menu, we see the equations used to calculate all the states and processes. The solution to the problem is a temperature of 519 degrees Celsius and a work output of 4,710 kilowatts. What is the intercooler for? The intercooler affects the second compressor, so we select process 3-4, that is, the second compressor. In a control volume, work is equal to the integral of the specific volume multiplied by the pressure differential. That is, the area to the left of process 3-4, which is equal to a work output of 613 kilowatts. We select the intercooler process, that is, process 2-3. We eliminate the intercooler by calculating the outlet with the same pressure and entropy as the inlet. We see that the area to the left of the compressor has increased, so the work consumed has also increased. Selecting the compressor process, we see that its work has increased to 966 kilowatts. That is, the intercooler cools the air to decrease the work consumed by the compressor. If you like this exercise, give it a like and share it with your friends.